Hi, today we're working with something really cool, dry ice. In fact, it's 97 degrees below zero cold. They have to make it that cold in order to make it solid. Once it's brought down to that temperature, and then brought out into room temperature, like, here, it starts to boil so rapidly that it practically goes directly to gas, a phenomenon scientists call sublimation. Our first lab is going to look at the way that the dry ice boils so rapidly it practically goes directly to gas. So what we're going to need is some water, soap, a bowl, and the dry ice. Once we combine the water and soap, we just drop our dry ice right in. The dry ice is boiling so rapidly that the CO2 gas evolves right off of it and rises out as bubbles. Dry ice is made out of carbon dioxide gas. Carbon dioxide is one of the main gases that we breathe out when we breathe out. Plants actually breathe in the carbon dioxide and breathe out the oxygen that we need to breathe in. Dry ice is a frozen version of that carbon dioxide. As the gas is released into the water with the soap, it creates bubbles. Let's test the viscosity of honey at a low temperature. As the honey gets colder and colder, it gets stiffer and stiffer. Here's one of the more interesting properties of dry ice. When I place it on this metal spoon, listen to the interesting sound that it makes. The dry ice makes the most interesting noise. I'm going to leave this one for you guys to think more about on your own. Let's see if some boiling water speeds up our reaction. Try adding a little soap. Let's see what happens when we add some soap. As you can see, the bubbles are being produced even faster. Dry ice is a great way to learn about the properties of very cold materials, materials that evaporate very quickly, what we call sublimation, and of course, creating lots and lots of bubbles. I'm Michael Mandel, and this is Works of Science. Thanks for joining me.